Good morning, students. In the previous class, we have learned the basic definitions of similarity, congruence, and different types of congruent figures, and mainly the congruence conditions. Also, four types of congruence conditions. Also, we have studied to show that the given triangles are congruent or not. Okay, now we are going to solve some example problems on congruency and the problems based on the conditions of congruency. After that, we will go to the exercise. So now it is the examples of congruency here. Two examples are there here. The first one is triangle XYZ and triangle LMN. Here is the XYZ and LMN are congruent under the correspondence XYZ is corresponding to LMN. Write the correspondence of all the elements of both the triangles. So, which sides are corresponding to each other, which angles are corresponding to each other, we have to write. Because already it is given that these two triangles are congruent to each other under the correspondence of XYZ is corresponding to LMN. Okay. So, what is the meaning of correspondence of XYZ is congruent corresponding to LMN? X is corresponding to L, vertex X is corresponding to L, Y is corresponding to M, and Z is corresponding to N. So based on this, we have to write all the corresponding sides and angles. So now, since triangle XYZ is corresponding to triangle LMN, so take all the corresponding sides here. First I am starting from X here, XY, side XY is corresponding to side LM. Here it is most important to take all the sides in same order. So here we are starting from this vertex. You have to start from here only, because X, Y, Z is corresponding to LMN, means X is corresponding to L, Y is corresponding to N, Z is corresponding to N. So when we are starting from X, the corresponding vertex L only you have to take to tell the corresponding sides. So XY means you have to start from L only, LM, because the corresponding sides only you have to take. XY is corresponding to LM, YZ is corresponding to MN, because Y is starting from here and the corresponding vertex M is starting here. You have to start from here only. YZ is corresponding to MN. Next, ZX is corresponding to NL. You should not take LN like that. Reverse order, you should not take. ZX is corresponding to NL. Okay. So now, if we take the angles, angle X is corresponding to angle L, angle Y is corresponding to angle M, and angle Z is corresponding to angle N. So these are the corresponding elements of both the triangles. Now, if we take the second example, this is also similar to this same. So if triangle PQR is corresponding to triangle DFE, write all the corresponding congruent parts of both the triangles. So here also it is given that PQR is corresponding to DFE. Observe the order first. PQR, DFE. Same order you have to take. Since these two are congruent to each other, corresponding parts of the congruent triangles are equal. Okay, what are the corresponding parts here? PQ is corresponding to DF. So this is the first corresponding side. Next, QR is corresponding to FE. We are starting from Q, means you should start from F here, because Q is corresponding angle or vertex to the F here. So QR is corresponding to FE, and RP is corresponding to ED. Same order. See the order here. RP is corresponding to ED. Only RP. Now angle P is corresponding to angle D. Angle Q is corresponding to angle F. Angle R is corresponding to angle E. Order is very important. Next. So these two examples based on the congruency of triangles only are taken. Here, these examples based on the conditions for congruence of triangles. 4 conditions we learned. So, based on those 4 conditions, we have to solve whether the given two triangles are congruent to each other. So, in example 1, for the following figures, two problems are given here. For the following figures, write the congruence condition and the corresponding parts. So, by following which congruence condition of given 4 conditions, they are congruent to each other, and the corresponding parts also you have to write. So, first you have to observe which sides are given and which angles are given and which are equal to each other. We have to find. First you have to observe the given figures. So here it is triangle CAB. Take the same order here also. M, N, L we can take. Here it is starting from here. Here we are starting from here. Why you are starting from here? You observe here. Here this is 4 centimeter side. Here this is the 4 centimeter side. Means these two are corresponding sides here now. These two are corresponding sides, because these two are having the same shape and size here. Next, this is 3 centimeters, this is also 3 centimeters here. So, AB is corresponding to NL here. And this BC we don't know, it is not given the length, whether they are corresponding sides or not. But we have to find out whether the given triangles are congruent to each other or not. And one more thing is given, the angle between these two sides, which is angle A, is 90 degrees. Here also the angle between these two sides, which is angle N, is 90 degrees. Both are equal here. Okay. Here, even though these two are right angle triangles, we should not use the RHS condition, because in RHS condition we should have to know about the length of hypotenuse, but here hypotenuse is not given. Here this one is the hypotenuse because it is opposite to the right angle. Here this one is the hypotenuse, this is the opposite to the right angle. This length is not given, means the data about the hypotenuse is not given, so you should not use the RHS condition. Which condition you have to use? Here this side, this angle, and this side is given. Here also this side and this angle and this side is given. If you observe, this is SAS condition. In this triangle, these two sides and the included angle of this triangle are exactly equivalent to these two sides and the included angle of this triangle. So, these two triangles are following the congruence condition, which is side angle side, which is SAS congruence condition. Okay, side angle side of this side angle side of this triangle are equivalent to this side angle side of this triangle are equal. So it is following which condition? Side angle side congruence condition. So these because of that condition, these two are congruent to each other. Means the congruency condition is satisfied and the condition is established here. Once the congruency condition is established, all the sides of all the corresponding sides of this triangle are equal to corresponding sides of this triangle, and all the corresponding angles of this triangle are equal to corresponding angles of all the angles of these angles are equal to corresponding angles of this triangle, because it is established already because of this condition. So automatically the side BC is corresponding to LM. BC is also corresponding to LM and also equal to each other. Okay, because the congruency is established already. So BC is also corresponding side of LM and BC is equal to LM. Okay, so now we can write all the corresponding parts here. Which are the corresponding parts? CA is corresponding to MN. Use the order same. From this we are starting here. So CA is corresponding to MN. AB is corresponding to NL. And BC is corresponding to LM, because we are taking the order which is triangle CAB is congruent to triangle MNL. triangle MNL. Okay, so that's why you have to use the order CAMN here MN. Next ABNL. So NL you have to take. You can observe the order here. Next, which one is that? BC. Next LM. BC, LM are the congruent or corresponding sides. And remaining angles, angle A is corresponding to angle N here, angle C is corresponding to angle M here, okay, angle B is corresponding to angle L here. You can use this order to find out which order you have to take. CA, MN, AB, NL, BC, LM. Okay, that cyclic order you have to take. CA, AB, BC, MN, NL, LM. The cyclic order you have to take. Okay. So like that you can find out which order you have to take. So this is the first one. Next, second problem. Here also two triangles are given, but they are combinedly given. One side is given as combined side, a common side to each other. So here actually one triangle ACD is given, but it is divided into two parts by using this AB side. Okay, and if you observe which sides are equal, you can find out. So here it is AC, here it is AD, both are equivalent to each other, 5 centimeters and 5 centimeters. And this angle is equivalent to this angle also given, 60 degrees, 60 degrees. So one angle is equivalent to each other and one side is equivalent to it. And this side, if you observe, this side is common to both the triangles. So this side is also equivalent to in each of the triangle, and this side is not given. This is undefined. So now which congruence you can use here? This is side is equivalent to this side, and this is angle. This angle is equivalent to this angle, and this side is equivalent to this side itself. This AB is corresponding to AB itself. AC is corresponding to AD. AB is corresponding to AB itself, and angle CAB is corresponding to angle CDB. Okay, now if you observe this congruence condition, same here. SAS. The side angle side of this triangle are equal to side angle side of this triangle. So these two triangles are following side angle side congruence condition. That's why triangle ABC is congruent to triangle ABD. Same order. So which are the congruent parts here? So the corresponding parts here you can tell by using this. AB is corresponding to AB itself. Next, BC is corresponding to. So first, actually, we will write after establishment, you can write BC is corresponding to BD also. Okay, before that we cannot write it. Okay, now CA is corresponding to CA means DA. You can get. Okay, DA is corresponding. CA is corresponding to DA. Three sides. And angle, if you take here CAB, angle CAB is corresponding to angle DAB. Angle DAB. Okay, so these are the corresponding angles. And remaining angles also corresponding to each other. Angle C is corresponding to angle D, and this angle ABC is corresponding to angle ABD also. So like that you can write the corresponding parts of the given triangles also. Next, example 2. The given figure AC is equal to BD. Here also two triangles are constructed on the same base. Here this is the base, and this is first triangle which is ABD, and this is second triangle which is ABC. Two triangles are constructed on a same base which is AB, which is common to both the triangles. and also given that AD is equal to BC. This side AD is equal to BC. So which of the following statement is correct? Justify it. So the following statement is correct. You have to find out. So triangle ABD is congruent to triangle ABC is given, and triangle DAB is congruent to triangle CAB is also given, and triangle ADB is congruent to triangle ADB is congruent to BCA is given. So which order is correct? We have to find out the order. So how to write? First you see here AD is equal to BC and AB is equal to BA. So start from here. AB is equal to BA. Okay. Next, BD is equal to AC. BD is equal to AC. How it is possible? BD is equal to AC. Here it is given in your problem itself, which is AC is equal to BD here. Okay. And this AB is equal to BA. How it is possible? Because these two are common sides of the both the triangles. So which congruence we can use here? All the three sides of this triangle are equal to all the three sides of corresponding sides of this triangle. So triangle ADB is congruent to triangle BCA. So same order you have to take. ADB is congruent to BCA. So these two are congruent to each other. So like that you have to take third statement you have to take. This is the correct statement, because these two are in the correct order. Is because it is starting from A here, A, D, B. So this triangle also you have to start from here only, which is the corresponding vertex of this one. What is the corresponding vertex of A here, B here? So you have to start from here only. So what is the corresponding vertex of D here? Vertex of D here it is C here. So when you are starting from A, D, B here, you have to start from here only, B, C, A. So this one is the correct order. Should not take these two. Even though these two are looking like same, should not take these two. Okay? So this is the correct one. Next, justified. That's what we have justified here in the first three sentences. So A is corresponding to B, D is corresponding to C, B is corresponding to A. Because of that, triangle ADB is corresponding to triangle BCA. Okay? So hence the option 3 is the correct. Next, example 3. Ray AZ bisects triangle DA, triangle D. Sorry, here in the textbook itself it is given the triangle ADAB, not that. This is angle DAB. This is angle DAB. Okay, angle DAB. So next, as well as angle DCB. This is only angle here, not triangles here. Okay, ray AZ. Here, what is the ray AZ here? This one is the ray AZ. You know that ray has a starting point and another point, another side it will go on indefinitely. So this is the ray AZ named here, ray AZ here. It is bisecting the angle DAB and DCB. What is the meaning of bisect? Bisect means dividing into two equal parts. By means two. What is the meaning of by? Bi means bisect or bisection. Section. By means two. Section. Making into parts. Making into parts. Bisect. Making into two parts. But also two equal parts here. Okay. Ray AZ bisects angle DAB. It is bisecting this angle DAB into two equal parts, which are angle 1 and angle 2 here, and angle DCB into two equal parts, which are angle 3 and angle 4. Angle 3 and angle 4. That is the first sentence here. Means in these two triangles, which are ADC and ABC, already this angle is equal to this angle and this angle is equal to this angle. So two angles are equal. Next, if you have this AC is a common side of these two triangles which are ADC and ABC, common side. So this side is equal to these two triangles. So now this angle and this side which is included in between these two angles are exactly equal to this angle, and this side is included in between these two angles are equal to both the triangles. So by angle side angle of congruency condition, these two triangles are congruent to each other. Triangle ADC is congruent to triangle ABC. So by using the angle side angle congruence condition, triangle ADC is congruent to triangle ABC. So these two triangles are congruent to each other. So now the congruency is established. So by using the corresponding parts of congruence triangles, we can tell that the corresponding parts are equivalent to each other. What he is asking here, already it is proved here, triangle BAC. If we take the order like this, triangle BAC is congruent to triangle DAC. Yeah, you have to take any order, but they should be in the same order. So now, third one is CD is equal to CB is asking. CD is equal to CB or not, he is asking. Exactly, they are equivalent because they are following the congruence condition, which is angle side angle. Once the congruency is established, all the corresponding sides or all the corresponding parts are equivalent to each other. So here CD is the corresponding part of CB here. So CD is equal to CB because these are the corresponding parts of the congruent triangles. By CPCT, have to read as CPCT, corresponding parts of congruent triangles. Since once the congruency rule is established, the corresponding parts of congruent triangles are equivalent, we can write CD is equal to CB. That's the reason here. That is the reason we wrote here. Okay. So now, you have to remember here CPCT implies corresponding parts of congruent triangles. It is used for convenience once the congruency of two triangles has been established by any of the rules, any of the four rules. If the congruency is established, we can use this CPCT rule. Okay. So now go to the example 4. It's very important problem here. Show that the bisector of the vertical angle of an isosceles triangle bisects the base at right angles. Show that the bisector of the vertical angle of an isosceles triangle bisects the base at right angles. So what is the meaning of this statement you observe here? Bisector. What is the meaning of bisector? It divides into two equal parts. Here, which one is dividing here? This line, which is AD. This line AD. This is the bisector of vertical angle. Here, which one is vertical angle? Here, this angle A is the vertical angle. These BC are the horizontal angle. So horizontally are there here on the base, but this is the vertical angle. So the bisector of vertical angle. So what is the bisector of this vertical angle A here? AD is the bisector of vertical angle. So this line of this isosceles triangle means two sides are equal. Here AB is equivalent to AC. Okay, this line gives that these two sides are equivalent to each other. Okay, so the bisector of the vertical angle of this isosceles triangle means this AD. Bisects means this line again divides equally the base at two right angles. What is the base here? This BC is the base of this triangle. This AD divides BC into two equal parts, making two right angles. Right angles means 90 degrees angles, making right angle. At right angles, it divides equally, divides equally means it bisects BC into two right angles. So that's what we have to prove here. Show that the bisector of the vertical angle of an isosceles triangle bisects the base at two right angles, Okay, to prove that, see here in triangle ABC, AB, here AB is equal to BC because it is an isosceles triangle, and AD is the bisector of angle A. This AD is the bisector of angle A, means it is dividing into two equal parts. Means this angle is equivalent to this angle also here, because it is bisecting this angle equal into equal angles. Okay, so now to prove the angle ADB is equivalent to angle ADC is equal to 90 degrees, comma BD is equal to DC. Here what you have to prove here? This angle ADB is equal to angle ADC is equal to 90 degrees, and BD is equal to DC because it is bisecting. Is it bisecting or not? We have to find out. That's what we have to prove. BD is equal to DC also we have to prove, and angle ADB is equal to angle ADC is equal to 90 degrees. So to prove that in both that this triangle is divided into two parts first, not equal. We can not tell that both are equal or not. Into two parts here. In the first part, triangle ADB, the first part of triangle ADB, and the second part of triangle ADC, AB is equal to AC. It is given by this word, which is isosceles triangle. AB is equal to AC. So this side is equivalent to this side. Here we have to apply the condition of triangles, congruence of the triangle. So this side is equivalent to this side. And since this AD is dividing or bisecting this angle A into two equal parts, this angle BAD is equal to angle DAC. Okay. So this angle is equivalent to this angle. And one more thing, this AD is a common side of these two triangles. So this side is also equivalent to both the triangles. So SAS of this triangle are equivalent to SAS of this triangle. So these two triangles are congruent to each other because of the SAS congruency. So now the congruency is established in between these two. So now once the congruency is established, we can tell that the corresponding parts of the congruence triangles are also equal. So automatically this BD is equal to CD here. BD is equal to CD. Hence DC also. Okay, BD is equal to CD. If you take the order, BD is equal to CD only you have to take. And the angles also equal because the corresponding angles are equal here because these two are congruence triangles. So angle ADB is equal to angle ADC. Okay, but are they equal to 90 degrees or not? How can you tell that? If you observe, this line is intersecting, this line AD is intersecting BC at this point. So BC is a straight line, you know that. If a straight line is intersecting by a line, these two angles will become as the linear pair. These two angles will become as the linear pair. But here we proved that this angle ADB is equivalent to angle ADC. Okay, so angle ADB plus angle ADC is equal to 180 degrees. You know that because these two are linear pair. Sum of linear pair is 180 degrees. But angle ADB is equal to angle ADC means in place of angle ADC we can take again angle ADB. So angle ADB plus angle ADB is equal to, because these two are equal here, proved here because these two are congruent triangles. So 180 degrees. So 2 times of angle ADB means 2 of angle ADB you can write. X plus x means 2x you can write like that. 2 times of angle ADB means 2 times of angle ADB is equal to 180 degrees. So now angle ADB is equal to 180 by 2. Send this into to this side by 2. So 90 degrees. So if one of the angle is 90 degrees, because these two are equal to each other, another one is also angle ADC is also 90 degrees. So therefore angle ADC is also equal to 90 degrees. So that's what we proved. AD bisects BC at AD bisects BC at right angles. Both are right angles now. This is also 90 degrees. This is also 90 degrees. We proved here. Okay, it's very important theorem. Okay, good day to all of you now. And in the next session, I will explain the next problem. Okay.